One of the coolest examples of how humans have harnessed the power of electromagnetism is in audio speakers. No matter what type of speaker you have, TV speakers, headphones, Beats, AirPods, they all use the same fundamental technology that's been around for a very long time. To understand how speakers work, we must first take another look at how alternating current works. When an electric current alternates, it gradually goes to its peak voltage or current, then gradually starts to alternate and go down to its negative peak, and then back up again. We have just graphed how the current can alternate in a copper wire. In an earlier video, I mentioned how the lights in your home are flickering on and off 120 times each second. Well, now you see why. You see how the current comes all the way up here, then goes to zero? Zero means there's no current flowing at that specific time. Current goes up and then goes down 60 times each second. And there are two places where the current is zero. But remember, it's so fast your brains can't even recognize it. Another important thing to notice is you see how this current makes a wave shape? This is called a sine wave. It's also called an electric signal, and it's kind of a big deal. Think about some other waves you may have heard of. Ocean waves, light waves, doing the wave at a baseball game. Basically, a wave is any disturbance that transmits energy. Now, sound is also a form of wave energy. Sound actually is nothing more than repeating vibration patterns in the air that transfer all the way from a device to your ear. But we'll learn more about that during our wave properties unit. What's really neat is that recording software can take these air vibrations, which are also known as compression waves or longitudinal waves, and they can transform them into something called a transverse wave, these types of waves. This is huge because your voice, a musical instrument, or an entire song has a distinctive and unique vibration pattern, kind of like a fingerprint, and when you put it into this type of waveform, we can play it back. Okay, but how does this relate to magnets or electromagnetism? Let's take a look at Mrs. Russomanno's self-made speaker. Look here, we have a solenoid that's attached to the cup with alligator clips that extend all the way to this headphone wire and into the smartphone. Metal is touching metal throughout the system. This looks pretty good. Now, when you place a permanent magnet near this electromagnet, the magnets will attract and repel each other with the same exact frequency as the song vibrations. When you press play on your smartphone, alternating current flows through the wire, but it's not the smooth, simple-looking sine wave we saw earlier. It's a unique signal from your favorite song. Remember, the signal is your song's unique pattern of vibrating sound. This unique signal alternates very quickly inside the solenoid. This vibration then vibrates the air in this cup, producing the sound that you hear. Now it's time for you to make one. As long as you understand the science behind it, you should have no problem constructing your own version of an audio speaker. Think about what you could use as your speaker cone. We use the cup. Think about how you should make your solenoid. There are many other videos online and on YouTube which show different ways to make these speakers, but the fundamental properties are the same. Think about some materials that could be affected by vibrations as you want your speaker cone to transmit the best quality sound. Once you're finished making one, test it out. Jot down some data about your speakers. How many turns of copper wire did you use in your solenoid? How strong were the magnets did you use? Did you use more than one magnet? Where did you place the solenoid and the magnets? What did you use as the speaker cone's diaphragm? Do you hear certain songs better than other songs? Great speakers are clear and loud, so design an experiment that can test one variable that can improve on your speaker's volume. You have learned a lot about electromagnets and the properties they all share. Use this knowledge to help you in your investigation. Good luck and rock on.